Hello and welcome to the Many Faces of Science podcast, where we discuss the different jobs that use science, the people who have them, and how they got there. We hope these episodes act as a guide for people wanting to explore more than just academia and the gateway to the curious-minded. I'm your host, Caelum, and today we're going to be chatting with Tissue Bank Manager for the Biomarkers and Companion Diagnostics Group at the Edinburgh Cancer Research Centre at the University of Edinburgh, Tammy Piper. If you enjoyed the episode and or found it useful, you can let us know on our social media. We're on Twitter, Bluesky, Instagram and TikTok. Here we go. So, hi Tammy, thank you so much for coming on the podcast. How are you doing today?
I'm good, thank you. How are you?
I'm doing really well, enjoying the fact that it's not as cold as it has been for quite a while.
Yes, it's definitely, spring is on the way, very slowly but surely.
So, my first question for you is, what is your official job title?
My official job title is the Tissue Bank Manager for the Biomarkers and Companion Diagnostic Group, which is a research group based at Edinburgh Cancer Research Centre at the University of Edinburgh.
That sounds like a really, really cool job. So what are your current job roles within that? Maybe the main three, if you could tell me.
I kind of joke that I'm a bit like Amazon, but for patient clinical trial samples. So we collect bits of tumour tissue from patients in large phase 3 breast cancer clinical trials.
Okay.
And these are global. So we've had some trials which have run purely within the UK. We've got others that recruit patients from Europe, China, and we've had some from Australia. And my job is to receive a sample, log it, and we either keep it in cupboard until a research project later on in the trial starts off, or we process it and make derivatives such as a stained hematoxylin and eosin slide known as an H&E, or we extract RNA and DNA and keep them in our freezers. And we can also collect blood samples and plasma and serum samples from patients if they're on a treatment that has particular time points that the researchers are interested in, like before receiving the treatment drug or after or partway through. So I do a lot of that and reports on what we've got and how many things we've got. But then part of our research, we do some translational research ourselves, and I do a lot of image analysis and digital pathology. So one of my other major tasks is to work on that and the data we generate from that.
Oh, okay. So do you work with specific researchers to collect specific tissue for them, or is it you're generally collecting those tissues and then researchers ask them?
So when a patient is diagnosed with breast cancer, depending on the biology of the tumour at the diagnostic sample, she might be eligible for a clinical trial. And so the research nurse and the oncologist have a meeting and say to the patient, would you like to consider entering this trial? Some of the trials are things like drug A versus drug B, or drug A every 2 weeks versus drug A every 3 weeks. And so the patient goes away with the information, thinks about it and consents. And then when she has her routine surgery, a piece of that tumour tissue is then sent to us. Okay. And that's what we're keeping. So we only collect samples from patients who consented to specific clinical trials, and only people who have the approval of the clinical trial research group can access the tissues. There are other biobanks I share an office with who collect routinely of patients who are having any type of surgery for certain diseases, not just cancer. And that's a slightly different type of biobanking.
Yeah, I know when I used to work in the biobank, we used to kind of proactively collect. So we had lots of inner samples, and then there was one research group that we did work with, so that if there were specific ones they were looking for, we went and gave them to them fresh.
Yeah, we're very trial specific, and we generally only collect breast cancer tissue that's been fixed in formalin and put into a little wax block.
Okay, so rather than having it fresh, so it has to go straight into the -80 freezers, you have it in the blocks, which then can be studied by the researchers.
Yeah, so it's easier because we receive a lot of our samples through the post, so it's easier to send fixed tissue through the post and internationally. Plus, we're going to make derivatives from it, such as the stained slides or extracting RNA and DNA. It's easy to do that from a block, because we can store the blocks long term, and then when we need to extract some RNA or DNA, we can cut fresh slides from that tissue because it's been preserved, if you like.
Is it preserved in paraffin or wax? Is that how it's preserved?
It was fixed in formalin, and then it gets processed and then ends up a wax block, which is called FFP, which is formalin fixed, paraffin embedded, which is far too many letters, so we just say FFP.
I imagine that's quite hands-on. So you said you also do kind of looking images yourself.
Yes, so part of our work is quite an interesting area of pathology. So I work in histology, but I trained in cytology, which was cytology is cells and histology is tissue, and we do a lot of microscopy and looking down microscopes. And a lot of our techniques are kind of hands-on and old-fashioned. So the other disciplines in pathology have big fancy machines like biochemistry and the blood sciences, whereas we still have to handle tissue ourselves by our hands. There's only so far we can automate the process. So we still have a microscope, a bright field microscope, and we still stain our slides by hand, and we still look at them down a microscope to check them. So in that sense, it is quite a hands-on discipline, which I quite like. Digital pathology is now coming in as more of a tool to help pathologists with diagnosing different conditions, because the image can be taken of the H&E, the hematoxin eosin stain slide
Mm-hmm.
and upload it to a server, and then the pathologist can review that. And we use it for analysis. But there is a big thing for rolling out digital pathology, particularly in areas where they don't have many pathologists. So
Yeah.
you might have one pathologist in 5 or 6 rural hospitals, for example. And then that way the pathologist can cover all of those areas with an image rather than having to physically travel to each of those sites.
I guess that's really, really good, because then that means they're cutting down their commuting time, which means they can actually spend more time looking at the actual images and helping with the diagnoses.
Yeah, because particularly for some rural communities, and we also think of it as like some of our image analysis projects we're starting to look into the use of AI. And the ultimate goal would be to equalize healthcare.
Yeah.
So what's really interesting about a hematoxin eosin slide, a H&E slide, is that the staining method's been around for like 100 years. It's super robust. The reagents can be kept at room temperature. So it's a really useful stain to be able to do on a tissue. And if you've got areas that maybe have intermittent electricity or have less funding for fancier equipment and machines and things like this, they could do this stain at a bench with reagents that can be kept on a bench and not need freezers and fancy fridges and things like this. And then the image can be taken, uploaded by Wi-Fi, and then a pathologist in the big city hospital somewhere else, or even internationally, can look at it, and then the patient locally still gets a diagnosis. So it kind of helps equalize healthcare a bit, which I think is kind of really cool.
That's definitely really cool. I think that's really, really important. I know, especially when I was working in the biobank, we had 30-80 freezers, which cost 20 grand a year to keep running, and small places, especially up in the islands and rural places in Scotland and different countries, it just isn't viable for them to be able to do.
Yes, I think also some of the staining methods, like immunohistochemistry is another staining method that's used a lot in cellular pathology. And that uses antibodies to stain for specific molecules on the outside of the cell. And it's really specific, but you need to keep things at 4 degrees, and you need to have them overnight in a fridge, and you need an enzyme digestion and all of these things that cost an amount of money. And if something goes wrong at any point in the process, you can't salvage it. You just have to start again. So some areas of the world, depending on what sort of infrastructure they've got, will not be able to have thousands of pounds for these staining kits because they don't have they might have a fridge, but the electricity goes on and off, or they might be prone to like bad storms or whatever.
Yeah.
So it kind of means that those patients may be missing out on the same level of diagnostic service that people say in a city or in a more Western country might be able to have. So we're kind of excited about the use of AI on H&E sections, but we're still very early days with it.
Imagine as that keeps building, that could then identify patterns, and through creating a program, it could identify or highlight things to the clinician who could look at it and go, actually, yes, that needs to be furthered on.
Yeah, so when I was a cytoscreen, I used to screen cervical smears. When I lived in Wales, this was before the HPV vaccine came in. So everybody had cervical smear tests then. And it was moving over to a new type of technology called liquid-based cytology. So it had better cell preservation. And what we used to do as cytoscreeners is we would review the cases, and the majority of the cases would be negative. So for us, we were just checking that it was negative. And then the next level biomedical scientist up would review our case quickly to double check we hadn't missed anything. Anything we thought was positive got passed up the chain to the clinical scientist and the pathologist, who would then say, yep, that's definitely positive for abnormal changes. So there is a use of digital pathology now within the screening program, because it's all pattern recognition.
Okay.
So when I was doing my training, we were taught like the 6 criteria for an abnormal looking cell. And it's all to do with the regularity of the cell membrane and arrangement of the chromatin, and if there's nucleoli, and the size of the nucleus compared to the cytoplasm. And these are all measurable features.
Yeah.
And I think when I was at the time, I was like, well, why can we not get a computer to do some of this work? Because it is a measurable thing that we're doing. But I don't think the technology was there then, whereas now it is. So it could be some of the pathologists that I've talked to at a digital pathology conference, half of them thought it was going to take their jobs. And the other half of the room was like, well, I just use it as a screening tool to help me filter out the cases that I really need to be looking at and focusing in on more detail, particularly when you have surgery for something and your tissue is removed and it's processed, and pathologists could have 20 to 30 slides for one patient to look at in detail.
Yeah.
But he doesn't know which slide necessarily the abnormal cells are in. So digital pathology with an AI program that can help review those cases and go, actually, that's not got any cells in that piece of tissue, or those are mostly inflammatory cells, which isn't useful, would actually help the pathologist speed up his workload, which helps the patient get a quicker diagnosis.
That'd be really important. I know from talking to my friend who used to work in histology as well, just they sometimes have a backlog of about 2 weeks occasionally, just because there's so much coming through and there's so many tissues.
Yeah, we normally ask research sites and hospitals to send us one tumour block for the patient, but sometimes they send us the entire case, and we can have 20 to 30 blocks for a patient, and we just need the one that's got the most tumour in it. So we then have to review all of those 30 blocks. And it's an amount of work for us as a research lab, but we're not having the hundreds of patients that a pathologist might be getting in a week. And that's just for one disease that we deal with. Pathologists might review 2 or 3. They might have speciality in 2 or 3 diseases. So yeah, part of my work involves a bit of digital pathology as well.
Do you personally use a microtome to cut the different slides at all, or is that something that someone else would do?
I do that. So I'm a senior biomedical scientist. So I'm now a level 2 biomedical scientist. So I've moved more into, I say, an admin role, but that's where I'm responsible for producing the reports. I review lab manuals for trials to make sure that the logistics of how the samples are taken, collected, and stored are correct. And I do a lot of quality assurance and quality checking of either the images and my colleagues' work. So I can do a lot of cutting and staining, but we're a very small group. There's only 3 of us. So we have my technicians at the bench, and she does a lot of the processing, the cutting, and the staining, and then I do a lot of the data and admin and quality checking. And then I have a boss above me who directs the science research for our group.
Everyone can do everything if you need to in case someone's off, but
yes,
you've got your own kind of specialized areas.
Yes, so on a week-by-week basis, generally, Monica does the bench work in the lab, and then I'll do the QA and the checking and things at my desk. But then when Monica's on holiday, I can cover her. And when I'm on holiday, she can cover some of what I do. And then my big boss, she didn't come through a histology background, but I'm sure we could for a laugh see if she wanted to try and cut a section. Like I said, she deals more with the research projects and the coordinating with collaborators and directing the research for our group and getting the funding in.
So my next question is, you've given us a lot of information there. Thank you so much. Did you always want to have this job, or did you want to be something else when you were younger?
Oh, completely wanted to be something else. I really liked Indiana Jones movies, so I wanted to be an archaeologist. And I was all into history until I was about 14. And then I discovered that marine biology was an actual science you could get a job in. So I switched, and I wanted to do marine biology, which is what I studied at university in Aberystwyth. By the end of my degree, I was trying to find work, and I'd got more interested in conservation genetics and ecology, but my dissertation was a literature review, so I had no lab experience. So I then applied for jobs to get lab experience. And I ended up getting a job in the pathology lab in the Royal Grant Hospital, South Wales, because that's where my boyfriend lived at the time. And I applied for the lab assistant job, which is like sample receipts, refilling reagents, filing, that type of thing, just to get some lab experience on my CV. So they said, well, you kind of overqualified that. Would you like to be a trainee biomedical scientist? And I thought about it, and I thought, well, it would be another couple of years training, but I would come out with a qualification I could technically use in any hospital in the UK. So I took that job as a trainee biomedical scientist and did my master's part-time while working full-time at Bristol. Worked full-time at the Gwent and studied part-time at Bristol, and then qualified as a biomedical scientist in 2005. And then I was looking for a job, and we wanted to move to a different town, and I saw this job in research, and I thought, yeah, sure, why not? I'll try it. So it's not a case of I've always had this dream of doing the job I've got. It's more a case of different opportunities that presented themselves. And I was like, yeah, sure, why not?
Kind of go with the flow.
Yeah, when I was a student, I had this friend. She was like super brain. She did maths at Cambridge and computer science in Edinburgh, and has a PhD in computational biology. And I said to her, how did you decide to do this job? And she said, oh, I didn't. She said, I just took advantage of a series of opportunities that came my way. And I was like, that is a really good way to look at it. So that's kind of how I've decided to do my work. When I first started at the group, I was very much lab based and did a lot of microscopy, but then we started to use digital pathology. And my colleague Monica, she can do RNA and DNA extractions, whereas I'm not very good at pipetting. So I do all the data side of things, and she does all the fine, like the very steady hand work. And I do all the Excel work, because we just kind of play to our strengths within the group.
It's been a little bit of a wavy path, but I think careers are never entirely linear. I imagine you really enjoy your job as well.
Yeah, I like the job I've ended up in. It's kind of ironic, when I was studying that my one module I hated was cell biology. I just thought it was the dullest thing ever. And now I actually work in a job where I do nothing but count cells and train computers to count cells, which is kind of ironic. I think you have to enjoy your job. Yeah, you have to enjoy it, because if you're studying a subject and you don't enjoy it, you won't necessarily be motivated in it. And I do think, particularly for my generation, we were kind of in this transition from, whereas our parents and the parents before us, you got one job and you basically stuck in that for life, whether it was shop work or, you learned a skill and that was you for life. So the idea of changing jobs and retraining was kind of a bit of an alien concept for them. Whereas now, retraining and switching careers partway through isn't necessarily seen as a big deal. And there's a lot of transferable skills between science into other non-science roles.
Definitely, and that's something that I want to look at with this podcast, looking at the opportunities which aren't just academia, not just going from undergraduate to masters into being a professor, different things in industry and the different jobs that use science that you wouldn't think about, like working in a hospital as a tissue bank manager.
Yeah, I mean, I work in a cancer research centre. It's the Institute of Genetics and Cancer, and I run our little section of the lab, but I don't have a PhD and I'm not academic. I'm kind of like, I consider myself logistical. I have to understand the science behind what I'm doing, because I can't troubleshoot bad staining if I don't understand how the stain should work, for example. And I have to have some, and I'm going to caveat, I have some understanding of what the computer software I'm trying to do to make it count my cells does, but I don't have any programming experience or knowledge. So you have to have enough of an interest in the science and what you're doing, because how are you going to fix it if it doesn't work properly? But I'm not an academic person, I'm logistics.
So kind of having that scientific knowledge within that logistics is, I think, a really, really good thing, as you were saying, because then you know what the computer needs to do. And if it goes wrong, you know how to fix it. And I imagine you could write the SOP for someone else to use of, if this goes wrong,
Yes,
try
exactly.
this.
And particularly when you're using computer software to, like, we train it to count cells for us, for example, and we want certain types of cells and not other types of cells, or stains cells that are stained one way and not another. And it will give you the answer you tell it to. So we have to set thresholds or categories for the cells to fall in. But if you don't understand the effect of staining on the presentation, or the variation of staining within a section, it could be because of the biology, but it could be because of bad reagents. Or you might have a batch of slides and none of them seem to be positive, and you know they should be positive. So you have to be able to troubleshoot what it is. And sometimes people come to me and they say, oh, I've got this image and the computer's not working on it, for example. And then you have to take a step back and go, well, how did you scan your image? How did you stain your image? Where are your reagents and date? All of this sort of thing. And working with clinical trial samples, we're quite tightly regulated in our documentation and our validation of our protocols. So we have to know the staining, like for our staining reagents, for example, we need to know the lot numbers, we need to know the expiry dates. We have to put a control slide in with everyone, and we have to keep them. So should we be inspected, we have this like all folder of like drawers of slides from different dates, so they could see that we're maintaining the quality of that. So we joke that our job is, in my tissue bank, we all like lists, with the sorts of people who write lists for everything, because we do like a list. We like ticking things off a list, so it kind of suits our personalities a bit.
I remember when I was working at the tissue bank that I was working in, we just had so many folders just of where every piece of tissue were, and then we were part of the 100,000 genome project, so kind of helping try and doing the sequencing, and just the amount of drawers of slides and blocks, they went up to the ceiling, five shelves high, and there was thousands of them just having to go through to this one, no, this one, no, this one.
No, it
Oh,
is.
that
We
looks
have
pretty.
drawers and
No.
drawers and drawers of slides, and we've got cupboards where we've cut the derivatives and boxed them up and sealed the boxes. We only use them for extractions. And I've got paperwork for everything, and lab books. And for a period of time, my previous boss, he moved to Canada. So when I started working at the university, my group was much larger. There was about 12 of us, and 9 of them moved to Canada to set another group up. And I remember I just spent 6 months shipping samples to them. I joked that I should be called Tamazon instead of Tammy, because that's what it felt like. It was just inventory and parceling up, inventory and parceling up. So yeah, we go through a ridiculous amount of shelves in our group.
Are you underground to keep the temperature fairly regular, or do you have windows?
No, so the building I'm in is a newer building, so they've decided that we can't open the windows because it makes the building retain heat better. So obviously it's too cold in the winter and too hot in the summer. But the room that we keep the blocks in, we've just moved from a storeroom in the main hospital to a room within our institute now, which is quite good. And we can monitor the temperature in that room, and we just keep that at room temperature. Our fridge and freeze, we have 2 -80 freezers, and they have temperature monitors on them and an alarm system. So if the freezer breaks down at 2 in the morning, the engineer automatically gets called out, and then I get a phone call at 2 in the morning to go check my samples, sort of thing. Touch wood, it's not happened for a while. And what's quite good is that the company will actually print out a temperature log, because it takes the temperature every 10 minutes or something and keeps it on a computer somewhere, so we can see what the temperatures were, to check it's within range, because we keep certain reagents in that fridge for some of our work.
I know I used to be the emergency contact because I lived the closest, so occasionally I just get a thing of one of the researchers has opened the fridge, wonderful, and they've left it open.
I don't live the closest, but apparently it's my number on the freezer.
Just hoping that they make sure that everything's shut and you don't have to
Well,
go
I'm
back
just hoping,
in.
I'm just like, I'm a bit like, just don't open the freezer door, because it takes quite a while from -80 to get to 0 if the door, and generally, because these are alarmed, we had one go off once at about midnight on a Thursday night, I think. And the engineers came out, and by Friday morning, the temperature hadn't dipped below -60, and we could have a printout of the temperature log from the monitoring system, which was quite good.
My next question for you is, has there been a person or a moment which changed your career? Obviously, you talked about the person saying you're overqualified for the role you're going for. You could be a biomedical scientist. So it may be them, it may be someone else.
I think in terms of my career, I think the best advice I got was one of my friend in my undergraduate about taking the most of opportunities. And I thought that was a really good way to look at it, kind of not tie myself down to this one ideal job in science and then not consider any other options. And then I think because I do public engagement through work as well, somebody who inspired me for that, when I was doing my undergrad degree, we have guest speakers once a month as part of the Biology Society sort of thing. And this lady came and she was a deep sea biologist. And she was, now all of my lecturers at university pretty much were older white gentlemen. And she came and she was in her 30s, you know, she dressed very nice and she had a really good way of speaking. And I was stunned because I'd never seen a female scientist look like that and talk like that and hold her own in a room full of, you know, crusty white men, to be honest. And I was just like, wow, I want to be like her when I grow up. So I found that she was really inspirational. I can't remember her name because it was 20 something years ago, but I was just really astounded by her because I hadn't seen many female scientists of her age present like that to a room. And I just thought, wow, that's how I want to be.
Yeah. Well, it just goes to show the importance of having representation, not just having, as you say, all the older white gentlemen, having people being able to see themselves in both the people who lecture them and the kind of different job markets that are available.
Yeah, absolutely.
My next question for you is, how did you get the current role you are in? So you've talked a little bit about what you did at university, but if you kind of go from maybe what you did from A levels onwards that helped you get there?
So I grew up in Norfolk, so I did like GCSEs. We had to do double science if you wanted to do science A levels. And to get onto
Hmm.
a marine biology course, you needed maths and two other science A levels. And I hated physics, so I did biology and chemistry. And then the maths I did was maths with statistics. And then so I did marine and freshwater biology. And then when I started my degree, a lot of the first year overlapped with students who were in biology or botany, or we had a lot of similar modules. But as the degree progressed, we then did more specialist things. So that's what I did with that. My dissertation, I did a literature review on fossil fish, which I really, really enjoyed, but I had no lab experience with it whatsoever. So when I was applying for jobs, they were like, well, you don't have any lab experience, which is why I decided to try and get some lab experience and apply for a medical lab assistant role because I thought it's an entry-level lab job. It doesn't matter that I've got a fishy background. In the pathology lab. And at the time, the NHS needed a biomedical scientist. It's a 3 to 4 year training program for them. So that's when I signed up. And that's how I ended up switching from fish biology to pathology.
And then did the biomedical for was it 3 or 4 years that you did?
I think it took me 3 years. So I sent my degree transcript off to the Health Professions Council in London and they assessed it and they said that because my dissertation wasn't lab based, I needed to do another degree with a dissertation in. And because I'd studied at the University of Wales, Aberystwyth, and I was working in South Wales, I thought I don't want to do another Bachelor's of Science at the University of Wales, Cardiff. So they said I could do part-time Masters of Science in cellular pathology at Bristol. So I went for 2 weeks every 4 or 5 months, and it was kind of like it was like a scientific vocational top up for me. And then I also had a logbook to do in house where I had to stain 50 slides, 100 slides, 1,000 slides, and be assessed and signed off. Because biomedical science is a state registered health profession, like a
Hmm.
physiotherapist or a dental nurse or an occupational therapist. The system's changed since I did it, but I think now that you have a 4 year degree, but the third year is a year in employment doing your vocational training. And then when you come back to uni, you finish. And then when you leave uni, you can then choose which discipline you want to specialize in. And then you go work there and do your specialist portfolio. I only ever trained in cell path. I can't go work in a micro lab, for example, without doing another specialist portfolio just in micro.
Okay. And that would, if you had to specialize again, that would be another year
It
or
would be it would be whatever. Yeah, it would be another training. But there's all this information on the IBMS website has all the career routes and training listed on that. So
what was the name of that website again?
it's the Institute of Biomedical Scientists. So it's
Okay.
www.ibms.org.edu. And that's got a whole thing about career.
Yeah, I'll put a link to that in the description just so if people are interested, they can have
Cool.
a look at that and they can have a look into those that are available. And then how did
Yeah.
you how did you get the actual role that you are in? How did you get this specific role?
I was so I did my state registration exam on a Tuesday and I had applied for a job as a lab technician for a research group in Scotland. And I had my interview on the Wednesday. And I think the project they needed at the time, they needed somebody who had done a lot of microscopy. So in my previous role as a cyto screener, we would screen at a microscope for 4 to 5 hours a day. So they obviously were like, right, we need somebody who could sit at a microscope for a lot. And that was me. So that's kind of at the time the group was expanding, so we had a lot of technicians. So I came up and pretty much I helped prepare the samples and then I sat at a microscope and counted tumor cells for a couple of years whilst testing the waters on what was their new digital pathology software that could count the cells for us.
So my next question is, what is the most fun day you have had at work so far?
Ooh, I think I tell you what, I've had a good day recently. Not fun. Fun's a difficult word to use when you work in cancer research because it's not a fun topic. But I've had a
Yeah.
day where I feel a real sense of achievement and that went well. Can I answer with that
Hmm.
one?
Yeah, you can answer with that one, definitely.
Cool. So we have, every so often, we have a student in place for a period of time working on an undergraduate dissertation. We've got one this year, we had one 2 years ago. And I think it's quite exciting when a student came and showed her how to mark tumor cells and use this software to count immune cells, because that's what we're focusing on now, is immune cells in the tumor microenvironment. And we trained it up a little bit and we analysed her first run of data and it showed some promise. And it was kind of like,
Yay.
and I think at that point, because I've done this job for a number of years, so I can turn around and go, oh, well, if it doesn't work, I'll try this, try the other. And I know that it's quite can be a long, arduous process. And explaining it to somebody who's only there for a matter of like 8 to 10 weeks, there's a lot of background they have to get up to speed on. So when we did her results, and it looked like it showed a bit of promise, and it all, that feeling that it all started to click for her, and that was actually quite a nice feeling. So I went home that day going, oh, that's actually quite good. I've showed somebody how this thing works and they've developed some of it themselves and going in the right direction, and yay. So yes, that was quite a good day.
That sounds like a really lovely day. I know when I was training the new people who were coming into the biorepository and they did their first successful tissue collection, I was like, yes, they get it. And then I can also go and collect more tissue, but they understand the process. It's working.
Yes. Yep. And I guess it's also because I have an enthusiasm for this job that other people might not have. So it's kind of nice when they can see why you're so enthusiastic about that. You're like, oh, it's not just me. It's actually quite a cool thing to be able to get computer to count immune cells for you in a tumor section. That's great.
I know when I used to try and explain what I did as a job to people at parties. Well, first of all, the first one was you work with Kleenex, and it's like, no, I don't work with Kleenex. The other kind for human tissue. And then it's like, no, it is actually really cool. Like what we're doing, it's important for the patients, and it's progressing, and it has a lot of value to it.
Yeah, I think it's my go-to answer is I collect bits of tissue from patients in clinical trials, and then
Mhm.
if they go, oh, what ones? And I go, breast cancer, and they're like, all right, okay. And then what we do with them, they never really ask, because as soon as I tell them to say, well, we start making derivatives, and their eyes glaze over.
It's like I found out the interesting bit. Now I don't care what the next bit is, but the next bit is the important bit. That's what we do with it, to let it do that.
It was interesting. We had we do a doors open days, the thing they have in Edinburgh every September, where buildings that are generally not open to the public are open to the public on weekends, and some of them have
Mhm.
activities. The University of Edinburgh has lots of their big research buildings open. So I turn up with my little 1950s setup with my bright field microscope and a selection of
Mhm.
slides of different tissues, and it's really interesting to see people's reactions. So I have a collection of tissue that is like a piece of lung, brain, spleen, testes, kidney, liver, heart, and it's seeing people like look down the microscope and seeing part of them that they wouldn't normally see, if that makes sense. So I'm saying, oh, this is what heart looks like down a microscope, and they're like, oh my gosh, this is amazing, and that's I quite like that feeling of people being able to see themselves in a very different way, if you like, down a
Yeah.
microscope.
When you're taught about biology, when you're in like primary school or high school, you are made of cells, but you can see skin cells. So you might just imagine that all cells in your body look like skin cells. No, they are. There's so many different types, and they are all different shapes and colors and textures.
Yeah, absolutely. And particularly because I've got like a section of heart muscle and then smooth muscle, and it's different shapes because it moves in a different way. So explaining to people that how your heart contracts versus how your arm muscle moves. And you could just go, wow, this is so interesting. Or brain section is quite a good one as well. So no, so I do like that, because for a lot of people they haven't used a microscope since they were at school, and it's not really, unless it's part of your day-to-day job, you're never going to think to yourself, oh, look down a microscope at some brain cells.
Yeah. So my next question is, what does your ideal day look like? This can be a ideal day just solely focused on work, or this can include from waking up to going to sleep.
My ideal day, I get up, I leave the house, I do like a cheeky Greg's breakfast on my way in.
Mhm.
I normally get to work, I check some emails in case there's anything coming in case some of our samples need to be returned. And then I catch up with my colleagues, see if there's any pressing projects. I only work part-time because I have children. So my week doesn't start on a Monday. So I catch up with people about stuff that needs to be done. And then what I really like to be able to do is plug myself into a podcast and either clean a ton of data in Excel or do a lot of image reviewing. I'm not a big fan of reports. So they would not feature in my ideal day. So yeah, then if I get to have a meeting or interaction or something, say with a student, we hosted some foundation apprentices a couple of years ago as well. So that was quite good, having them in the afternoons and just showing people a little bit of what we do, sort of thing, is always quite nice. And then finish up, get home, have no delays on my bus journey home. That would be ideal as well.
Just everything running smoothly.
Everything running smoothly. I have a reasonable amount of time to listen to a podcast and just do data cleaning, and I don't have any disasters, and my bus isn't stuck in traffic, And
Yeah.
Ideally, I wouldn't spill my lunch on myself either because I do eat soup for lunch most days and it's always a hazard. Hence my comment about not being able to do extractions because I don't have a steady hand. I think the challenge I have with extractions is when you have a column, a little tiny tube, and you got to use this like Gilson pipette, which is the one they use on like all the CSI style police dramas. You always have a Gilson pipette somewhere, and you have to take like this fraction of liquid off without touching the really really delicate layer underneath. and, and that's the bit that I'm like, no, this is not. What happens? Oh, I can contaminate. No, that's not me then. I just can't. That's the bit that always gets me. In cytology, we did like process like lots of fluids and stuff like that, but it was a bit more. We used pastettes, which can take like 1 mil above or whatever, and because we were liquid-based cytology, we spun stuff down and we put it into a machine and it sucked up the cells and stamped it onto a slide. So I didn't have to really like do a lot of very detailed pipetting. And now things are shifting to more molecular science with extractions and stuff like that. It is involving a lot more fine pipetting than I may be designed for. But I'm quite good at Excel, so I feel that I keep my value at work.
Excel is the backbone of the NHS. Well, or at least from my experience, it was.
We use it a lot for tracking our samples because we have different trials have different tissue sampling requirements. So it's very difficult to try and get a standardized piece of software for that. Also, software costs money and Excel doesn't. So yes, I do have quite good Excel skills. And if anybody wants to get really good Excel skills, you can LinkedIn Learning has tons of how to use Excel videos of all different levels. So I've worked my way through quite a few of them during lockdown to get even better Excel skills.
So in your role, do you have to collect any metadata, lots of different information about the peoples that you're using the tissue of?
Yes. So when a patient's in a trial, we get the tissue and the trials office that's coordinating the clinical trial normally collects the data. So they collect them on case report forms or CRFs, and it's normally like a performer that you fill in, and it might be they'll have baseline data collected when they enter the trial, and they might have pathology data once the surgery's been done, and then follow-up data. So side effects from the treatment, if the patient's getting a novel treatment at each time point, and then they'll just send a questionnaire out every year for about 5 to 10 years. And then if the patient's tumor recurs, they'll get some more follow-up data and we might get a second sample of that. And all that data is held by the clinical trials office. And then should we do any analysis on the tissue, our results, we can then send it to the trials office and they put it with the patient follow-up data. So we can then do statistics on it to see if there's anything that indicates whether a patient's tumor will or won't come back, depending on what treatment arm they were in, for example. So yes, there is some data being done like that. And what's quite interesting is we have some trials which we have, say, 4,000 patients in, and we found a result is that another trial group might have a similar trial in Europe with 4,000 patients. So then they'll finish their trial and they'll say, well, why don't we analyze the data from your trial and our trial together in a meta-analysis of say 8 to 10,000 patients? And then the data from that would be more robust. And that's when our research starts getting taken to like maybe goes to NICE and they consider whether they need to change the guidelines for something or allow this new treatment to be approved or things like this. So data collection is quite important and data handling as well.
What is NICE, just to double check?
It's the National Institute of Clinical Excellence. So they do a lot of guidelines on things to do with the NHS and treatments and drugs. And there's guidelines for surgery and the use of new diagnostic tests. So if it has to be approved by NICE to be used in the NHS. So like in America, they have the FDA, the Federal Drug Agency. And I think there's another one in Europe as well. So our research that we do doesn't always end up immediately in the NHS. It's kind of a long game because we then have to do a meta-analysis with another trial to have a bigger data set to then take to NICE to say, actually, we think this would be better every 3 weeks instead of 2, for example.
I know one of the main things that I did as well as tissue collecting was metadata, going through patient records and finding the information that was relevant because they were trying to work on Crohn's and IBS. And so they were trying to find any link between any of the people who had that condition. We had about 200 different systems in the hospital and none of them talked to each other. So it was just logging it, like so many different logins and just going in trying to find any of the relevant information.
I feel your pain. We have a thing where we have breast cancer trials from back in the 1980s and 90s where tissue wasn't collected because they didn't really do that type of research then. It was more outcome that they were interested in. And now they're like, well, we could go back and collect the tissue from these patients and do modern techniques on them because we've now got 30 years of outcome data. And everybody gets very excited. And then you go, do you have the block number for that patient? And they're like, oh, no, we didn't have computerized records. So we had a project where I had to go and rummage in basements and people had to find old logbooks. I had to go to a hospital to collect samples in England, and I had to do a day's training on their computer system to go find the one computer in the back end of pathology that still had those records on from 1997. So I feel your pain for that.
There was one we had which it was just a black and white screen, and you couldn't do a backspace on it. It was just kind of like the Matrix. It would just went across slowly, going down. Like essential infrastructure for working that out, because that's where all the information is. As if you tried to move it, it'd probably corrupt.
We used to use the telepath system, which was green on a black screen.
What is something from your past that you unexpectedly use in your current role?
I guess I use a lot of my cytology work. When I was doing my cytoscreening, we learned a lot about how to use and maintain a microscope and explaining the criteria of an abnormal looking nuclei, a tumor nuclei. So I've introduced that into, and when I'm training technicians or students, for example, on how to do that. My undergrad degree, I really like fish and I talk about them a lot. So if I do certain public engagement activities, I'll try and make them fish focused if I can. I do like a rock pool. And I have done like workshops with children who are home educated about fish and ecology and things like this. But I can't really get fish much into my day job, is unfortunate. My youngest was at nursery till quite recently, so I actually went to his nursery because they were doing they do a project, a little topic, and they were doing sea creatures. So I came down and taught them the difference between a fish and a shark, and how fish swim depending on I quite like ecomorphology, where you can figure out how a fish swims and what it eats based on its mouth position and its fins and its tail shape. And then they all got to make fishes out of paper plates. So, yeah, so I quite like stuff like that.
That's also very important. I managed to get one of my questions wrong in my first year, because it was a question of what is this fish from the skeleton, and I put shark and realized that that was very much not the answer.
No, no. A good way you can tell the difference between a fish and a shark skeleton is if you wobble your nose. So if you wobble the bridge of your nose, it's bony. So like that's what a fish is like. And if you wobble the end of your nose, it's cartilage, and that's what a shark skeleton's like because it's on the outside and it doesn't preserve very well. Which is why there's very few fossils of sharks. You can only find their teeth.
Oh, I didn't know that. That is an unexpectedly very cool fact. My next question is, were there any internships, training courses, volunteer work, or previous roles that you did which helped you to get to your current role? So we've talked a little bit about it.
Yes, so not really in my circumstance. I left home at 16. I went into what was called supported lodgings, but in essence it was a foster home for like children 16 to 18-ish. And having been care experienced, when I went to university back in the 90s, there was very little support, for example. So it meant that during the holidays at university and when I was at sixth form as well, I couldn't go do an internship or an unpaid work experience placement because I had to get a job to be able to pay for rent and food. And I do feel this is a barrier in lots of jobs, but particularly in STEM as well, is that I've worked with colleagues who did a 6-month placement somewhere in some lab, unpaid, but they had financial support from their families, therefore they could go do that. And they could travel somewhere like London, somewhere very expensive to do these types of placements. Whereas if you're care experienced or have caring responsibilities and other like financial factors, it's not an option for you. And I do feel that can be a bit of a hindrance to getting into these sorts of jobs. However, to end on a positive note, is that this is being recognised more and things are more available. So, for example, where I work, we have Science Insights Week, which runs in the summer. They like I think it's for S5 and above, they can apply to come and they come for a week and they visit each of the different institutes across the campus and stuff like this. It is weighted towards people from lower socioeconomic groups or people who maybe have more challenges or barriers compared to others. And they also do a science placement for 2 weeks in the school holidays as well. And for care experienced students, I know that University of Edinburgh, for example, has a corporate parenting policy, which I think is more common amongst universities now. And part of that is that they actually offer more support, both financially and practically, for students who are care experienced or estranged or have caring responsibilities. So, for example, when I was a student in the summer holidays, I was homeless because I lived in halls of residence and then private accommodation, and that tended to run from the length of the school year. But now you can get all-round accommodation offers, for example. And when you turn up to uni, you get a gift box that's got a kettle in it and some pans and a duvet, which doesn't sound a lot, but it's an added expense when you don't have a lot of financial savings. It is better than it was.
That's really good that they've put that in place. If you could do it again, would you try and get on one of those schemes if you could now?
If I was studying now, absolutely. Because one of the biggest barriers for me was the fact that financially I had to work on the holidays and I had nowhere to live. Whereas if I didn't have to worry about that, then I would have the mental headspace to go, actually, oh, there's a placement here. Or I could take up that 2-week, a 2-week work experience there. Being unpaid wouldn't have been such the challenge that it was when I was a student, if that makes sense.
Definitely. Do you think that, I know there's some places that maybe the John Innes Centre, they have like a 2-week lab experience for year 10s that kind of happens during one of the holidays. Would you recommend getting into lab experience, doing work experience in like year 10, year 11, or maybe even year 9, not necessarily obviously kind of necessarily very advanced stuff, having that, building up those connections and kind of networking with people at that age? Would you think that would be beneficial?
I think what's good about seeing it at that age is it kind of gives you an idea of what it looks like in real life. So you can actually
Yeah.
see what a real lab looks like, and people ask your job. And so when we've had work experience students before, open data, people are like, oh, it sounds really interesting. And I was like, it is interesting, but we also repeat it on 4,000 samples in triplicate. So it's
Yeah.
novel at the start. When you're on slide 10,000, it can lose its appeal a bit. But I think it's good to be able to see these sorts of lab setups and think to yourself, right, is this something I could see myself doing? Or actually, it
Mhm.
wasn't what I thought. So no, I know that there is a 2-week placement thing that I know Edinburgh Uni does in their school holidays,
Mhm.
where you get a small project and you work around for a couple of weeks or whatever. So no, I think definitely that's a good way of testing the waters to see if it's what you wanted to do and to make contacts with people in the science. And also because science is such a wide field, you can go to a lab and go, I really want to do this type of science. You get them, you're like, actually, I prefer this other one. It
Yeah.
helps you narrow it down because there are so many different areas that you could work in.
That's one of the things that I'm trying to show with this podcast. Of there is just such a variety of different areas that you can use science, and there's so many different transferable skills between them. And it's really, as you said, it's really really important to find something you enjoy, but it's equally important to try something and go, no, that's not for me. And then you understand that, and you can understand what kind of angle or where you want to go from there.
Absolutely. I mean, I've got colleagues, former colleagues, and like one of them, she'd worked in science for 30 or 40 years, and she decided to go work in a bank. Another girl, she did academia for a while actually, and then she moved into science editing, where she just reads
Okay.
through articles before they're published. And she quite enjoys that type of work. I know people who've gone into public engagement and like science communication because that's quite important. So yeah, so no, definitely.
Do you know if there is, I mean, kind of a governmental website, or was it mainly kind of looking at the universities to see if they have those kinds of programs, or do you know if there's any centralized area that people can look at if there's stuff available in their area?
So I'm based in Edinburgh. So I know that we have, like I said, the Science Insights, and I think there's a lot of stuff through Career Scotland and My World of Week of Work. I think I sent you the link before. So they have a thing about apprenticeships and things in STEM and videos where they chat to scientists and things like this. I don't know about nationally because the education is different here to how it is in England or Wales. But I do think that there's been a shift towards more public engagement and outreach programs, particularly in STEM. So I wouldn't be surprised if there isn't opportunities to do placements or visits, for example, at other larger
Yeah.
research institutions down south.
I know there's the program of I'm a scientist, or like talk to a scientist.
Oh yeah, I've done that one. That's quite fun.
Yeah.
I'm a scientist, get me out of here. That's really good. Yeah, I've done it a couple of times. It's quite interesting, sorts of questions you get, and because it's just a chat room. So it is
Yeah.
moderated. So inappropriate questions are weeded out and people are booted off. But it's
Yeah.
quite nice because they can just ask anything like, how did you get into your job? What's the pay like? What do you do like this? If you did want to do this, what A levels did you do? And it is very informal because it's done like a chat room.
That I think they've also got I'm an engineer, get me out of here, and they're kind of expanding that out to kind of more different jobs as
Yeah, because
well.
I think I'm a scientist has different themes. So like I've done a cancer research zone a couple of times, but they'll have like a physics zone. So like, they'll do it every other month.
Yeah, because there's so many different areas. One of my previous guests I was talking to, they look at human building interactions. And so one of the things they look at, put sensors in elderly people's houses to see how they use space, so that they can then design buildings so that people don't have to move out to a different building. It can be built in from, they can stay in the place that they had when they were younger because it's been built with those facilities.
Well, that sounds quite good. No, I think engineering is, and also there's like an overlap. So we get people on placement who have a degree in something different, physics or chemistry or engineering, and they actually do a research project in the biology, and it's called a
Yeah.
cross-disciplinary fellowship, and it's trying to merge these different disciplines together.
I know my actually first guest I had on the podcast, Dr. Elizabeth Mills, she did marine biology for her first two degrees. And then for her PhD, she did an engineering PhD looking into the different compositions of concrete that they use in marina walls, because she wanted to understand why sea life stuck to walls and if they could change the composite of the walls so that they didn't have to kind of spray things to stop the sea life. They could actually just change the structure of the marina walls.
Yeah, I listened to that one actually when you sent me the link, and it was really
Yeah.
interesting because she studied in Swansea, I think she was in, and I was in Aberystwyth. Yeah, and then I've come to Scotland and she was in Scotland, and she mentioned she does D&D and I do D&D, and I was like, oh my God, it's like me but 20 years younger.
Well, let me know if you'd like to get in contact, because she's a lovely person.
Yeah, might find her on LinkedIn, send her a message.
My next question for you is, are there any networking events, mailing lists, groups, or guilds/associations that you feel would be particularly helpful for someone trying to kind of follow in your footsteps or kind of become part of a tissue bank? As in working in a tissue bank, not but their tissue become part of the tissue bank.
Oh, yes. Good clarification there. So the Institute of Biomedical Science, they have a website that's really good for having, it talks about careers and it's got blog posts about people who work in the job. But we do have a Biomedical Sciences Week and a National Biomedical Science Day, and we tend to do a lot of outreach from pathology labs into the community and schools. So like I've took my biomedical science down to like the local high school, just give people leaflets about it as a potential career option in STEM. So look out for that one. I know the NHS has an apprenticeship page that talks about apprenticeships in healthcare science. So that's like being like a radiotherapy technician. So like it's a technical job behind the scenes that people may not know about, sort of thing. So look out for those sorts of things. Anyways, we do, like I say, we have the Institute has a doors open day. So like local universities would have an open day every so often, and for members of the public, for example, to come in and see what research they're doing and chat to people then. And it's manned by scientists. We normally have activities on for kids and things like this. So you can chat to people who are there to find out about their work and how they got into it as well.
Yeah.
And then I did Careers Hive at the Museum of Scotland, which was about working in STEM as well. That was another way of chatting to people and finding out.
Yeah, it's a really, really good event. For the listeners' benefit, I'm slightly biased. I worked with Edinburgh Science on the Careers Hive event as a science communicator and the volunteer coordinator. It's a bit different from a normal careers event. There is tables with different activities where the volunteers can relate their careers to the activities, and then it kind of helps break the ice between the students and the volunteers, which is really, really good.
No, it was really excited that I got given the giant ear.
Yeah.
And I was a bit like, okay. And I had to really like think back, but my grandmother was deaf, and I had done care work when I was a student, and I learnt sign language as part of that. So I was there, right, frantically trawling through all of these bits and pieces in the archive of my brain. But it was really good fun. And different people would come up and talk about their experiences of it, of hearing loss and things like this, and how the ear worked. And people were really interested to do with like these AirPods, how good are AirPods for your ears and your hearing and things like this. So that was a really good way to engage people, I think.
Yeah. Even to do a slight plug of it, again, I say I'm biased. I helped work on that event. If you are kind of in high school or slightly more in your earlier years, reach out to your kind of teachers to see if they want to go to Careers Hive run by Edinburgh Science. It happens October time. And even if you aren't in high school, then there is also an open day on the Saturday where you can go and talk to science professionals from different areas. It ranges from obviously we're working in a biobank to we had people from the army there. We had people who were marine engineers. There was a really cool one which was called Future Farming. So looking at the different sensors that they use in farming to work out if the cow is happy, and then if the cow is not happy, what they can do to improve that as well. So it's a really, really cool area. I recommend going on the Edinburgh Science website to kind of learn more about it. I will put a link in the description.
No, it was a really fun event as well. My husband and kids came on the Saturday, and we lost my eldest. He went off and he tried the operating table. There was the keyhole surgery table as well. You really like that one. And there's something about bees as well.
Yes,
And pollinators.
there was. We had flowers and little paintbrushes, and we had fake pollen that they could kind of brush from one flower into another, kind of show how pollination works, which is really, really cool. There was also deconstructing an engine, learning how that worked. There was extreme environments where put a kid onto a turntable, you turn them upside down, then you ask them science questions or got them to try and tie a tie, which is surprisingly difficult upside down.
Yeah, I can imagine.
Yeah. So my next question for you is, are there any graduate jobs that now exist in the industry that you feel would benefit someone?
You have your biomedical science route, where you do state registration, you go in the NHS, but you've also got healthcare scientist, and you've also got medical lab assistants, which are jobs where you're supporting the pathology science work. So you've got those jobs. And then we, from the biobank side of things, we recruit research technicians. And these are people who can come in and they work for, the contracts might be like 12 months or so. So there is a thing with short-term or fixed-term contracts. And that's because it's linked to the funding for the research. I know in our university and others higher education places, once you've had so many renewals, you kind of are treated like a permanent member of staff. Once you've had so many renewals of 12 months or more. And these are where you're employed to work on a specific project for a period of time, and it's quite good for getting your skills up. So like when I started, I was doing biobanking and immunohistochemistry, scoring and staining, And then we've had somebody else come on and they've just done the scoring and staining. We've had another technician who just did tissue culture. And it's a good way of working and gaining lots of lab experience, because I think that what would benefit, I've done mentoring at work with other lab technicians, and it's having a really robust CV with a lot of lab skills on it is really beneficial
Yeah.
for like future employment. So trying to get as wide a variety of techniques as you can
Yeah.
is really good.
Definitely. I know when I was trying to look into different lab skills and stuff like that, it was very much how much lab experience have you got? What different techniques can you have? And because it's all well and good having kind of the basics of what they need, but if you can also meet the desirables that they want as well, it gives your CV just that kind of extra level of goodness.
Yeah, I think it does. Even if it's just there's like one or two of them, or it's like transferable skills. So my colleague Monica, she has a background in microbiology,
Okay.
and then she got a job working in a histology lab, and she just did cutting and like microtomy, just making the slides all the time. So when she came to us, she didn't have any of the IHC or the scoring. And she'd only worked with animal tissue. She hadn't worked with human tissues. But we saw in her CV that she had transferable skills from those other experiences. It was attention to detail, fine pipetting, and you know, used to handling a large amount of samples. And so we were like, well, we can train you in some of the other things that you don't have that are on our desirable list. So I think that's important. If you can highlight, well, I haven't done this exactly, but I've done something similar, and the transferable skills are X, Y, Z as well. I think that's a good way to go.
Definitely. Linking it back slightly to the career side, one of the things we tried to teach the kids a lot in one of the workshops was transferable skills. They're really important because you can, and also as we said before, kind of moving from different areas. If you have those transferable skills, that can really benefit you because you can use those in different jobs and explore different areas.
Absolutely. I am, like I said, when I got my job, they'd asked for somebody with histology background, which I didn't really have because I trained in a cytology lab. But they needed somebody who understood microscopy. And so, and because I'd done sample processing, I had some sample handling skills, just not the exact ones that they wanted. But they were like, well, we can train you on that because we actually really prefer your microscopy skills.
Yeah.
And that's how I think I ended up with the job that I have. Um, so that's important. And then good computer skills, particularly in Excel, um, because you will handle data to a point. I think attention to detail, being able to prove that you have a good attention to detail, because we work with clinical trials, we're very regulated, we have a lot of documentation. Good data entry and attention to detail skills are really important. It doesn't matter if you've not cut a section before. I can train you how to cut sections, but I can't train you how to pay attention to things really well. Does that make sense? So there are other skills that are not necessarily from a book
Yeah.
that are important as well.
Definitely. In terms of, I've got skill section on my CV, and kind of with attention to detail, I always put labeling and mapping thousands of tissue samples because it's
Yeah,
a really good having something that can physically show without a doubt that you have that skill on your CV is really important.
absolutely. And if you go to a job interview, they will say, oh, we see you on your CV, you mentioned this. Could you give me an example of when you used it?
Yeah.
So always have one prepared.
Quite a lot of interviews I've had tell us about a time when you thought there was going to be an issue, but you've managed to resolve it by being proactive or something like that. Or
Oh, yes.
yeah,
What's your problem? Yeah, problem solving skills or something.
yes, definitely. And just having that backlog of experience so that you can choose which ones to go and which fits the scenario the best is really good. My next question is, how can people find out more about your role?
So I have a blog post that was on the IGC website before Christmas, which explained a bit about my role and the challenges in STEM as care experience. But I have also been involved with Edinburgh University Medical School did a biobank day a couple of years ago, and on Instagram we all got to take over and write a piece about the different biobanks that we worked in within the university. So there is some on that. Through Career Scotland, I was interviewed about my job and routes into my job as well for my week of work, I think it was a couple of years ago.
Okay.
And that link is available.
Wonderful. And if people wanted to reach out to you personally to ask kind of questions, how would they be able to do that if you are okay with that?
People can find me either through LinkedIn or through the university website. I'm at the Institute of Genetics and Cancer, University of Edinburgh.
Okay, wonderful. I will put links to that in the description as well. My final question, thank you again for being such a wonderful guest, is do you have anything you would like to talk about or promote?
I would like to promote the ways that universities can support care experience students in attending higher education.
Okay.
I think it's a real important thing that's maybe not widely known. There's most universities, I think, have a widening participation team where they go and do outreach and I do think that if people feel there is a barrier to higher education because of that, these barriers can be overcome.
Yeah.
And it will be National Care Day on February the 21st, which acknowledges all of the children and young people in care in the UK. I'd like to mention that as well.
Yeah, I will. Obviously, we're going to try and get this episode out for then as a really good kind of highlighting of what can be achieved. And
Excellent.
Yep, and I will try and do my own research and find some links. And if you have any that you'd like put in, I will share that with social media with this episode as well.
I'll send you the widening participation one for the uni.
Thank you. So thank you for being a wonderful guest. I have learned a lot. I knew a little bit about working in a tissue bank from my previous role, but definitely stuff that I've learned that I didn't know about. And hopefully the listeners have also learned about a role that they didn't necessarily know about. I didn't know about it until I saw the job application, but I've literally just finished uni. So it's definitely a really interesting area to go into. Really, really vital work, both within institutes and within kind of the medical setting. So if you are interested in that, go do research, go to the different links that I've put in the description, and you never know. Maybe one of you one day will be working in a tissue bank. Thank you so much, Tammy, for coming on. It's been wonderful.
No, thank you for inviting me, and I shall speak to you again soon.
Speak again soon. Bye. Hi everyone, I hope you enjoyed the episode. I certainly enjoyed making it. If you've got any questions, feedback or recommendations for who you'd like us to talk to, you can send them to our email, themanyfacesofscience@gmail.com. Or you can contact us via our socials on Twitter, Bluesky, Instagram and TikTok. See you next time.